Okay, so here are your examples. For example, so we have a large number of, I believe, 65 million. Okay, so I need to move my decimal place 7 spots till I get 6.5. So 6.5 now is my n, as shown there. And since I jumped 7 spots and the number is bigger than 10, I'm going to report a positive 7 there. Okay. Now the second example kind of goes in a backwards direction, but that's okay. We'll look at it as the way that we've been doing these problems. So I've got a decimal there of 0.000000002, and I'm going to move my decimal base backwards till it's behind that 2, and that number is now between 1 and 10. Okay, so I'm going to get 2, and I've made 9 jumps now. So because I've made those 9 jumps, the decimal is going to, or the exponent is going to be 9, and because that number originally is less than 1, it's going to be negative 9. Now, things that you need to remember is that the number of digits in your n component, okay, so in that decimal component, that is going to be determined by the question and the calculation that you have done, okay, following those rules that we outlined for multiplication and division or adding and subtracting. Now, why might you want to do scientific notation? For example, maybe the numbers that I'm given in the question only have a degree of accuracy of 2 significant figures, but yet I get this number that's just huge, okay? So, you know, a number of a couple 100,000. I still can only report those 2 significant figures, and we know that trailing zeros count. So because of that, that's where scientific notation comes in, okay? So it gives me those 2 significant figures as my degree of accuracy, and then it also allows me to communicate the volume or the magnitude of the number that I am also talking about.